Hi people and welcome to this video. In this video we're going to be working on the trigonometry section of the May-June 2025 paper 2 exam. Okay, so we have question 5 which says if cos of theta is equal to negative 5 over 13 where, and we can already start using this to figure out where it is on the diagram because we can see this is a trig diagram question. Okay, so they say cos of theta is equal to negative 5 over 13, which you can see it's negative. So where is cos negative in the cos diagram? Cos will be negative in sine's quadrant and tan's quadrant. So that's where it's going to be. These are two options that we have. But they say where theta is greater than 180 degrees but less than 360 degrees. Remember that the angles go 0 degrees, 90, 180, 270, and then back at 360 when you go around. So from 180 to 360 would be measuring from here all the way to here. So you see that that does not include this quadrant. So it means that this is our quadrant. It's in tan's quadrant. Okay, so given those parameters, determine without a calculator, okay, the value of, and this is the first that we have. Okay, so let's go ahead and fill this diagram in. So we have our terminal arm or our radius, and then we're going to move up to the x-axis, and remember that that line is perpendicular to the x-axis. Okay, so that's going to be, we have cos, remember in SOHCAHTOA, that cos is adjacent over hypotenuse. So this is the adjacent and that is the hypotenuse. Now you know by default the hypotenuse is always positive. So the negative goes to the 5. So we've got a positive hypotenuse of 13 and then the adjacent side. So adjacent this angle that we are measuring. Always measure from the x-axis to that line. That's theta. So the one adjacent it would be here because this is opposite that angle. This is right next to it. So that is the negative 5. So you see that all we have to find is this y value over here. So let's go ahead and do that first so we can find out what sine squared theta is. So we are saying y squared is equal to, and our radius is 13. So that's 13 squared minus negative 5 squared. And we can just quickly find that. And you see that that gives us 144. So y squared equals 144. And then if you square root both sides, you know that you're going to get a positive and a negative answer. But we need to look at, what it is relevant to our diagram. So y equals, you see where y is. Y is here. So it's a y value on the negative part of the y-axis. So it's going to be negative 12, and there we go. Okay, so we have y now, and now we can find sine squared of theta. So sine squared theta is equal to, remember that sine is so SOHCAHTOA, opposite over hypotenuse. So we're going to take the opposite side over the hypotenuse. So negative 12 over 13. Negative 12 over 13 all squared, and that is going to give us, that's going to be 144 over 169. Okay, and you know that 169 and 144 can't divide, so that's our answer. It's positive because it gets squared. Moving on to the next question. Okay, question 5.1.2 says we have to find tan 360 degrees minus theta. Okay, so you know that this is that 360 minus theta is in cos's quadrant. So right now, this tan is going to be negative in that quadrant. So when we reduce this, this is going to be negative tan theta. And then we'll just find out what negative tan theta is. Remember, it's tan. So in SOHCAHTOA, TOA is opposite over adjacent. So opposite over adjacent is going to be this over that. So opposite over adjacent. Okay. So we're going to say this is equal to negative, and it's negative 12 over negative 5. But those two would divide and become positive. So the final answer is just negative 12 over 5. And that's our answer. Moving on to the next question. The next question, 5.1.3, says we have to find cos theta minus 135 degrees. Okay, so yeah, sure, I can see that this is a negative angle at the end of the day, and add 180 degrees, but I'm not going to do that immediately. There's a quicker way. Because the thing is, there's something that we have to do here that we just can't avoid at the end of the day. What that thing really is if you had to add 360 degrees, okay, you're still going to have two angles. One is not really fully a special angle yet. So you would still have to use the cos rule on that at the end of the day. So we might as well just use it now. Okay, so using this, expanding this using the cos rule would be, remember the cos rule. Okay, so that's going to be cos, and we have theta, and then cos 135 degrees, and then that changes to a plus, and we have sine theta, sine 135 degrees. Okay, now we can simplify these. So this is going to be equal to, and we have cos theta and then cos 135 degrees. Here's how we can split it. You see, it's not really that big for you to reduce it. So what you can do is, and how you know is, once that angle falls into this, okay, so it is greater than 90, but it is not greater than 180 degrees. It's less than 180. It means you can use cofunctions, okay? So if you had to remove 90 degrees from 135 degrees, it gives you 45 degrees. So this means that this is going to be cos, and you have 90 degrees plus 45 degrees. So this is plus, and then we still have here sine theta, and then sine 135 degrees is going to be, we have 90 degrees, and then that is plus 45 degrees. So this is equal to, and we have cos theta, and then you have cos 90 degrees plus 45 degrees. Using cofunctions, remember this is like cos 90 degrees plus a. Okay, so this will become negative sine 45 degrees. And then plus we have sine theta, and then this is going to become positive cos 45 degrees. Okay, so now do you see that we have special angles and we can actually work with that? Now, remember that the instructions say without using a calculator. If you use a calculator, your answer is going to look different from what the memo would look like, for example. So let's go ahead and just use the OHA rule. And the reason I'm using this here is because we're dealing with 45 degrees, which is going to have a denominator that is an irrational number. So if you had to use the calculator, it would actually affect your answer because it would rationalize your denominator. So remember, guys, the OHA rule looks like this. You just say OHA, and then you put your angles down. 30 degrees, 60 degrees, 45 degrees. And then it's just the numbers 1, 2, 3, 3, 2, 1, 1, 2, 1, and then you square root the biggest number in each row. So here it would be the 3, here it would be the 3, and here it would be the 2. So looking at the 45 degree column, we have sine 45 degrees. Remember that sine in saw, katoa, because we're also going to use that, is opposite over hypotenuse. So that's going to be the O over the H. You see how that becomes 1 over square root 2. Okay, so this is just equal to, we have cos theta multiplied by, of course it's negative, so you might as well put the negative here. And then that becomes multiplied by 1 over square root 2. Plus, and we have sine theta, that's not negative. And then we have cos 45 degrees. If you go cos, you're going to say adjacent over hypotenuse. So here by 45 degrees, we say adjacent over hypotenuse, which is again 1 over square root 2. So multiply by 1 over square root 2. Okay, so that's all we need that for. Now, when you're multiplying this, you see that this will be negative and then that will be positive. So I'll just go ahead and write that one first, okay? And they're all going to be over 2 because these multiply. So numerator times numerator, denominators multiply here. So you end up with a sine theta over square root 2. But here you end up with a negative cos theta over square root 2. Okay, so because they're both over square root 2, you can just put them over the square root of 2. So that's sine theta minus cos theta over square root 2. And that is our answer. Okay, moving on to the next question. The next question says, simplify the expression to a single trigonometric term. And we have this. Okay, so we can just rewrite that first. Okay, so this is equal to, and we have to, now you see we have 180 degrees minus x, which we know is going to lie in tan's quadrant. So that's 180 degrees minus theta that we have there. So that would become negative. So that's going to be multiplied by a negative cos x, and then that is sine of negative x. Since the angle is negative, just add 360 degrees to this. So if you add 360, you have 360 degrees minus x, which you know lies here. That's 360 degrees minus x, or theta, which is cos's quadrant. So it means that that's going to be negative. Okay, sine is going to be negative. So this is multiplied by negative sine x. Okay, that's why it becomes negative. It doesn't become negative because you take the negative here and you put it in front of the sine. If you do that, you're probably going to end up making a mistake if they ever give you something like this, because you're going to say, oh, I put the negative here, and so this is what this simplifies to, but this is wrong, because if you had to add 360 degrees here, you see that you get cos 360 minus x, which is positive. Okay, this is cos, and it's positive in cos's quadrant because it's quadrant, and so it's supposed to be equal to positive cos x, not negative. So be careful. It does not become negative because you take it outside. No, it becomes negative because when you add 360 degrees and reduce it, it becomes negative. Or really, you're just following the direction. X represents an acute angle and it is negative. So instead of measuring anti-clockwise, it was measured clockwise, and it ends up in cos's quadrant where cos is already positive. That's also another reason why. And then we go all over and we have this. Okay, so you can see already here we've got a cofunction going on, but we just still have 1 and then minus 2 and then the cofunction. Okay, so what is going to happen there is you have cos 90 degrees minus x, which becomes positive sine x. And then that sine x gets squared. That's why we have that squared over there. Okay, it gets squared and then it just becomes a positive sine squared x. Okay, so that's what it looks like. Now, do you see on the numerator, these two are just negative. So they multiply and they'll of course become positive. So when they multiply and they just become positive, all you have on the numerator is 2 cos x sine x, which is the same thing as 2 sine x cos x. And you can see that this is an expansion of your double angle sine 2x, okay, because of the double angles. So this is just going to be sine 2x. And this over here, that is also a double angle expansion. That would be cos 2x, okay, so that is cos 2x. Remember, all of these are in your formula sheet. So sine 2x over cos 2x, that is the expansion of the identity for tan 2x, okay, because it's sine over cos of the same angle. You can't do this if you have something like sine 2x over cos x. Don't do that, okay? If you have something like this, the best thing to do is to expand this so that the cos and the cos can cancel. You see, it expands to that, so cos and cos will cancel there. So the only reason we were able to make it equal to this is because the angles were the same here, but here they're not the same. Okay, so that is that answer, and moving on to the next question. Then we're on 5.3, and 5.3 says, calculate the value of the following expression without using a calculator. Okay, so you see there are a whole lot of tans, tan 92 degrees, tan 94, 96, all the way to 178 degrees. I think there was a question like this before. Okay, but let's just write down this first and then we'll see what is going on here. Okay, so now we have it down. Now, notice the way these numbers look. They're just moving in twos. So 92, 94, 96, all the way to 176 and then 178. Okay, since it's tan and it's not really like sine or cos, the only thing we can do now is to reduce these angles. And it's better to reduce them just so that we can see what they are. And also this actually looks like it's going to have something to do with cofunctions just because of the numbers that they're using. See, this is 92. That's 90 plus 2 degrees, 90 plus 4 degrees, and so on. So let's reduce it because that one can also be 90 plus something. So let's reduce them so that they are simpler. Okay, so it is equal to, and if you reduce this, remember it's tan, right? and it's just an angle that is greater than 90 degrees. So it will lie here in sine's quadrant. So it's going to use this reduction 180 minus theta. And then if you use that on this, you see that it's going to become negative tan of, we get 88 degrees, okay, because it's going to be 180 minus 92 gives you 88. So negative tan 88 degrees. And then we'll do the same to all of these. Now, because these ones are just increasing by 2 degrees, these are simply just going to decrease by 2 degrees. So for example here, so remember we are still multiplying. So it's multiplied by, and then we have this will become negative tan, and it's like saying 180 minus 94 degrees, which is going to give you 86 degrees. And then it's just going to keep moving like that. So again, multiplied by negative tan of, and then it's going to decrease again by 2 degrees. So it's going to be 84 degrees. Okay. And then if you move towards this side, that's also going to become negative c. Now this time it is still within this quadrant, okay, because it is 176. It's not more than 180 degrees. But you see that if you say 180 minus 176, you're going to get 4 degrees. So this one is going to be negative tan of 4 degrees. And then that's going to be, with these types of questions, I would like to actually leave one extra one, but it's fine, like a third last term, so that we can just see how it works. But it's okay. So we'll leave it like that and then multiply by the last one. That would be negative tan of, and we will only have 2 degrees there because plus 2 will give you 180. So 2 degrees. Okay. So this is what it looks like. Currently, they're all negative. So we can also just work with that. So since they're all negative, let's see, will it become positive? It can only become positive depending on the amount of terms that you have. You see that you have, if you read it backwards really, because it's going from 2 degrees and then 4 degrees, 6 degrees, and all the way to 84, 86, and 88. So how many terms or how many values are we multiplying together? Since you started at 2 and you ended at 88, it means there are exactly 44 values. So you see, if you have a negative number, let's say negative 1 times negative 1, it gives you a positive 1, okay? If you have negative 1 times negative 1, but this multiplies 3 times, it will give you negative 1. But the minute you multiply it an even amount of times, it gives you a positive. So we are multiplying something that is negative 44 times. So at the end of the day, it's going to give you a positive number. So this ends up becoming positive. And I mean, it's 88. And we might as well just write it this way. Since it's 2 degrees, 4 degrees, it probably wouldn't matter, but it just would look better and it would be better to work with. So let's go ahead and write it like that. So this is tan of 2 degrees. And then we have multiplied by tan of 4 degrees. You see, everything is just going to be rewritten. We might as well write a third term. So we're going to have, after that, tan of 6 degrees. And then let's just say dot, dot, dot. And then it continues from here. So everything now is positive. I'm just writing it the other way around so we can still work with this and look at what happens. Okay, cool. So we have that now. Okay, now what else can we do? Okay, something that I'm noticing about these numbers now is, you see, 2 degrees plus 88 degrees gives you 90 degrees. So it has something to do with cofunctions. And it's good that they use tan. Well, they obviously used it for this reason. They use tan for a specific reason because of the fact that tan can be expressed as sine over cos. And you know that sine and cos are the two functions we use with cofunctions, right? So this is going to have a lot to do with cofunctions. It's almost as if they have a theme. And this is something, I don't know. Okay, this is just a theory. It's something that I'm noticing with past exam papers. It's like they choose a theme and then they just go with that throughout that topic. In this trigonometry, it seems like the theme is cofunctions because it's appearing a lot. But okay. So this is where we are. And now, since we have 2 degrees and stuff, the thing is, these can be expressed as the same thing. Because you see, They are angles that can add up to 90 degrees. So how about we start expressing these as sine over cos, okay? So this, instead of it being tan of 2 degrees, it's now going to be sine 2 degrees over cos 2 degrees. Okay, and then the next one is going to be sine 4 degrees over cos 4 degrees, and so on. So let's write till here first. Okay, so there we are. And then, of course, we'll have to do the same here because it's still tan, so we can't just start changing it, you know. So we're also just going to say sine of 84 degrees, and then we're going to work on changing those, okay, using cofunctions. And this will be cos of 84 degrees as well, and then it will continue. Okay, so we have that now. Now, because you see this part, these angles are quite big, okay? They can actually be expressed like that as well if we use cofunctions. So we can just rewrite this because it's nothing really, you don't really have to change anything. You can choose to change this one, but I'd rather leave the ones with simpler looking angles and then change the ones with, 84 and 86 and so on. So then we have multiply by, and these ones are now going to change. So instead of this being sine 84 degrees, here's our advantage. You see, these are all angles that are less than 90 degrees. So we can use cofunctions on it. With cofunctions, you have the angles that are less than 90 degrees, okay? And you can see this as this is in the first quadrant when everything is positive. And then we have the angles that are more than 90 degrees, which is 90 plus theta that we'll have. That's how we'll represent them. So we're going to change them using cofunctions. So with the sine 84 degrees, you're just saying change it into a cofunction. So it's not going to become negative. They're all going to stay positive since everything is positive there. So it's going to be sine, and then we're going to have 90 degrees minus what gives you 84 degrees. And that's 90 degrees minus 6 degrees, okay? And so when you finally apply cofunctions on this, this is going to become cos of 6 degrees. And it's not going to change signs. And so will all of them because they are all angles that are less than 90 degrees. So that one can be expressed as cos 90 degrees, again, minus 6 degrees, right? But when using cofunctions, that's going to change to a sine. So it's now sine of 6 degrees. Moving on to this one. So when we say multiply by, this one is going to become, we have sine 90 degrees minus what gives you 86 degrees. That's minus 4. So it means that this will become cos of 4 degrees all over, and then that on the bottom is going to be, it's a cos of 90 minus 4, so it becomes sine of 4 degrees. Okay, and you can see here you only need 2 degrees left to get to 90, so those ones would simply just change to cos of 2 degrees over sine of 2 degrees. Okay, so now that we have this, you see how cofunctions can be very helpful. What will happen here is, remember that we have exactly 44 values or 44 terms, values, let's just call them values. Okay, so we're going from 2 all the way to one specific number, and then it'll stop increasing and then it'll start decreasing. Now to find out where that number is quite simple. Since this is 2 degrees, it starts at 2 degrees, and you know that there are exactly 44 terms. It will stop decreasing exactly at the middle. If there are 44 terms, then at the 22nd term, it will stop doing what it was doing. So if it was 44 values, then at the 22nd value, right, it stops increasing and then it starts decreasing. So you can see that the first term, right, the first value here, the angle that we had was 2 degrees. So it means the 22nd one, the angle that you'll have would be 44 degrees because it's just going to be double of it. See, first term, the angle is 22 degrees. So the middle one, 22, the angle will be 44 degrees. Okay, so just to see what happens there. So you will have a sine 44 degrees over cos 44 degrees, and that will be the 22nd value, right? Or term, if you want to call it that. Then the 23rd one is going to look like this. It's going to say cos 44 degrees over sine 44 degrees. Okay, now the reason I'm putting this here, this was the 23rd one, okay? The reason I'm putting this here is just so that you can see what happens as they cancel. So here, these ones are going to cancel. Do you see that we have sine 2 degrees over cos 2 degrees? And the last term is cos 2 degrees over sine 2 degrees. When you multiply these two things, because they have the same term on the numerator and denominator across, right? They're going to just cancel. So this is going to end up canceling like this. Okay, 2 degrees. And they cancel across. That cancels with this, and this cancels with that, meaning your answer here is just 1. And you'll notice that this will keep happening. So these two, numerator and denominator, cancel. Denominator and numerator cancel. Next term, okay, the second term will cancel with the second last term. Numerator and denominator cancel, and then denominator and numerator cancel. And this will keep happening. Still going to happen here as well. Numerator here cancels with the denominator. Denominator cancels with numerator. Until you get to the middle. And then in the middle, you can see what's going on as well. Same thing. Numerator cancels the denominator and denominator. So it cancels all through, meaning the answer, the final answer is 1. And that's the value of that. Okay, so that is it for question 5 in trigonometry. And then we move on to question 6. Question 6, 6.1 says, prove that, and we have this. Okay, so you have to prove that 2 cos squared 45 degrees plus x is equal to 1 minus sine 2x. Okay, so from this, you can see that the side that we actually have more to work with would be the left-hand side. Okay, so we'll say left-hand side and we'll just rewrite this. Okay, so this is what we have. And let's see how we can expand this. So you see we have a squared here, so we're going to have to keep that in mind. This is 2, and these are going to be squared at the end of the day, but it's still cos 45 degrees plus x. We can use compound angles for that, so we can use the compound angle expansion of that. So let's just put brackets already and say we're going to expand that. But of course, whatever we have in our expansion is still going to be squared because of the squared here. So that's going to be cos 45 degrees. It's cos x. And then the sign changes to minus sine 45 degrees and sine x. Okay, and then all of that will get squared. And now let's just see how this simplifies. So we've got cos 45 degrees, which we already know from that OHA that becomes 1 over square root 2. And then it multiplies to the cos x. Okay, so they're just repeating the same thing again, which we already got. Okay, but we know that cos 45 is 1 over root 2, and then it's going to multiply with cos x. So you might as well just say numerator times numerator, denominator times denominator. There's a denominator of 1 here. So that's just going to be cos x over the square root of 2. And then here, that's also going to become 1 over square root 2. And then it multiplies with sine x. So it becomes minus sine x over the square root of 2. And then they still get squared. Okay, so now it's just working with that square. So it's equal to, you still have 2. Now when you square, just be careful. And this is why I don't deal with that squaring as this times the same thing. Because then, you are at risk of making a mistake. So I would rather use shorter methods so that I can avoid mistakes. So you're going to square the first term. And when we square the first term, it becomes cos squared x. And when you square the denominator, because you're squaring this whole thing, you square the denominator, that square root of 2 becomes a 2. You do the same thing to the second term. You square that, and that becomes positive sine squared x. And square the denominator, it becomes 2. Now, the middle term, you're going to take cos x over square root 2 and multiply it by negative sine x over square root 2. Okay, when you multiply those together, then you get negative sine x cos x over square root 2 times square root 2 is the same thing as saying square root 2 squared. Okay, because it's the same thing times the same thing. So that just gives you a 2. But then remember, after saying first term times second term, you multiply that by 2. So what we have here, I'll just rewrite it like this, is minus, and we have 2 sine x cos x over 2. Okay. And now we can distribute that 2 in. So when we distribute the 2 in, you see this 2 is on the numerator. It's going to cancel with every 2 on the denominator. So it multiplies with this first one. That just becomes cos squared x. Multiplies with the second one. It becomes negative 2 sine x cos x. And we can already see the sine 2x, okay? And then plus sine squared x. Okay, and now we have identities. Sine squared x plus cos squared x, because this is positive. When they get added together, they become 1. And then you still have this minus 2 sine x cos x. So this is just 1 minus, and this is a double angle expansion for sine 2x. Okay, so you see 1 minus sine 2x, and that's what we have on the right hand side. So we can say it is equal to the right hand side. Moving on to the next question. The next question, 6.2, says, consider the expression sine A minus B minus sine A plus B. Okay, 6.2.1 says, prove that sine A minus B, okay, I'm just checking if it's the same, okay, that is equal to negative 2 cos A sine B. So they just want us to prove this identity. Okay, so we're taking the left hand side and let's rewrite that. Okay, so this is equal to, and it's going to be sine A, using the compound angle rule there. The expansion for that would be sine A cos B, and then the sine stays the same. Then cos A sine B. Okay, it is in the formula sheet, but it's best to actually just memorize it and know it by now. So with the sine, it's kind of like it sings a song, like sine, cos, cos, sine. But the letters stay the same. They stay in the same order. It's always A, B, A, B. Okay, so sine is always sine, cos, cos, sine. The sine never changes. Okay, this middle sign never changes. And then cos is cos, cos, sine, sine, and it still stays A, B, A, B. Okay, then we have minus. Okay, when you have minus, because you know that this expanded to 2 terms, that will also expand to 2 terms. So you need to protect it with brackets because it's going to affect what is inside. So that just becomes sine, and we have sine A cos B, and it's plus cos A sine B. Okay, so we're just going to distribute really. So rewrite this exactly as it is, don't change anything, and then just multiply that negative into the bracket and then see what cancels. So when that multiplies, that just becomes negative and it stays exactly the same. So exactly what is there just becomes negative. Okay, so let's look for our like terms. These, right, this, you need to look for sine A cos B. You have 1 here, sine A cos B. So because that's positive and that's negative, they both cancel. And then you're just left with this. So it's negative cos A sine B minus cos A sine B, giving you negative 2 cos A sine B. And there we go. It is really equal to the right hand side like they said it would. So it's equal to the right hand side. Moving on to the next question. Okay, so 6.2.2 says, simplify the following expression to a single term. Okay, and they give us sine 4x minus sine 10x. Okay, so let's rewrite that first. Okay, so if you looked at this for a while and you were trying to find, numbers that would work for this where you can actually simplify them, it may have been a bit of a struggle. And when that starts happening, I would always suggest that you go back to, where this question started. Do you notice that when they started, they say consider the expression this, right? So everything really just revolves around the way that looks. We were able to prove that this, okay, and now you'll see the similarity. Sine 4x, right? Sine of something minus sine of another thing. So this was also sine of something minus sine of another thing. We had to prove that that was equal to this, negative 2 cos A sine B. So it means that we can somehow express 4x and 10x as A minus B and A plus B. So let's think about how we can do that. Because the thing is, there have to be the same numbers that you're using. I can't change this to 3x plus 1 and then change that. Okay, so this one will not work with a plus, but a minus rather. So for example, I can't decide to change this to 6x minus 2x and be like, yay, it gives me 4x. And then this one, I'm just like, let me change it to 6x plus 4x. You see, now this is already a problem because things will not cancel the way you actually want them to, so that they can simplify. You're just going to go on a whole spiral where you're just working on this really complicated looking sum that is not simplifying any further. So that's why I say it's always good to go back to the scenario and then see what is going on and go back to the previous question. That's something that also comes up a lot in Euclid. Always go to the previous question and see what was happening there. Okay, so we need to find a way to express 4x and 10x as a minus b and a plus b. Okay, so you see the addition of the one that is bigger will definitely be the a plus b. So something plus another thing should give you 10x, and something minus another thing should give you 4x. But they should be using the same numbers, like a should be the same and b should be the same. Okay, so numbers that can give us, you can think about it like this, numbers that you add together that give you 10. It could be, like I said, that 4 plus 6 or 6 plus 4. But the reason I wouldn't go with this is because I can't say 6 minus 4 and then it gives me 4. It doesn't. It gives me 2. So 6 and 4 is not going to work. Okay, so let's leave that. We're still looking for numbers that you add together that give you 10. So 1 and 9, definitely not. 2 and 8, not really, because if you say 8 minus 2, yeah, you get 6, and 6 is not anywhere here. So that already doesn't work from the start. So we can try 7 and 3. So 7 plus 3 gives you 10, and 7 minus 3 gives you 4. So yes, that's what we can use here. So I'm going to expand this and say this is sine, and the one with the 4 is the smaller one. So that's going to be the 7 minus 3. So that's going to be 7x minus 3x minus, and we have sine of, and then the 10 is going to be the 7 plus 3. So that's going to be 7x plus 3x. There we go. So we're using the same numbers. So now you see it's in the same format, sine of something minus sine of another thing, okay? And this is the ones that we add together, and those are the ones that we subtract. So you can see this as your A and your B, okay? 7x is your A, 3x is your B. So in the same way that sine A minus B minus sine A plus B was able to simplify to this, is the same way we're going to change it here as well. So it's simplified to this, and I'm just going to go ahead and say that will ultimately be equal to this. And you're just going to change A and B. And of course, if you like, you can put a reason. Okay, so yeah, that's our answer. I noticed I left the B there, so I had to remove it. Okay, so that is our answer. It's only for 2 marks. And the next question will probably follow. So we'll understand why it's probably useful to leave it like that. Okay, so moving on to the next question. The next question, 6.2.3, says, hence determine the solution for this. Sine 4x minus 10, we already know what that is equal to sine 3x, which repeats again. Okay, so great. Since we knew this, we can just rewrite the equation first. Okay, so at this point, you know that this, okay, simplifies to that. So we can just go ahead and say, well, I can see this is negative, so I'm just going to rewrite it like this. So sine 3x is equal to, and then is equal to whatever that was equal to. So that is negative 2 cos 7x, and then sine 3x. Okay, now we can just take this over. So this is sine 3x, and then plus 2 cos 7x, and then sine 3x, and then is equal to 0. In these two terms, this and this, you can see that sine 3x is common. So we can take it out as a common factor. So we have sine 3x, and when we take that out, what is left in the first term? It's just going to be 1. And in the second term, we have positive 2 cos 7x left, and then is equal to 0. So we have something times something gives you 0. And so this is just going to be sine 3x is either equal to 0, or we have that 1 plus 2 cos 7x being equal to 0. Okay, so this is finally equal to, we have sine 3x is equal to 0. Well, we'll just work on that separately. But with this one, you can take the 1 over, it becomes negative. And then if you divide both hand sides by 2, then you're going to just get cos 7x is equal to negative 1 over 2. Okay, so that's what we have there, and that's what we have there. And all we have to keep in mind is this, okay? This restriction they gave us, 0 to 30 degrees. So we're just working with sine and cos, so it's not going to be complicated or anything. Let's start with the first one. We have 3x as our angle. So to find the reference angle, you just take sine over, or use the second function of sine on both hand sides. So this is going to be shift sine of 0, which is still 0 degrees. And then you can say 3x is equal to, and because sine is non-negative, we can just use, I'll just deal with this using the quadrants, okay, to make it simple. So using the quadrants, we're just going to use the first and the second quadrant because this is where sine is not negative. So 3x is equal to, and we have just 0 degrees. I don't even see a reason for considering this one because it's going to be too big, okay? 180 minus theta is 180 minus 0. They already told us that these angles are only going to range from 0 to 30 degrees. So I see no use of taking that. I'm going to ignore it. I'll write it down, but I'll ignore it afterwards. So 3x equals 0 degrees, of course. That's k 180 degrees, not general solution, but we're just putting that down for now. Or 3x is equal to 180 degrees minus 0 degrees, and then plus k of 360 degrees. Why did I say 180? 360. The sine graph repeats itself every 360 degrees. Okay, now I'm not going to even deal with this one because it's just going to be so big that it's not going to fall within 0 to 30 degrees because 180 minus 0 is 180. If you divide it by 3, that's 60. You see, it's already way beyond it. 0 to 30, so we can ignore that part. So I'll go with this and we can just divide both hand sides by 3. If you divide by 3, x is finally equal to, still 0 degrees there, but then plus k of 120 degrees. Okay, so we know, of course, where k is an element of integers. And then the second part, so that's this over here, the cos. Okay, so we have cos 7x is equal to negative a half. So it's negative. I'm just going to use the table method here, no problem. I'm not going to use the quick method that I usually use. So with negative a half, where is cos negative in the cast diagram? It's going to be negative in sine's quadrant and in tan's quadrant, okay? So it's negative in those places. So we're going to use the reductions there. That's 180 degrees minus theta and 180 degrees plus theta. So we first have to find the reference angle. If you took cos over and you say shift cos off, now because we are using the table, we're not going to say shift cos of negative a half. You're going to say shift cos of positive a half. You use the absolute value. So the reference angle would be 60 degrees, okay? Because if you said cos of 60 degrees, you get a half, okay? It's co-functions with sine 30. Okay, so to deal with that, let me just move these because it's going to get in the way. It's not giving enough space. Okay, so we have this now, and now we have to solve for not 3x anymore. I'm just putting this D here so I remember what that was. Now we are solving for 7x, okay? So we got our reference angle at 60 degrees, and we're going to solve for 7x. So we're saying 7x is equal to, and we will use these because we know where cos is negative here. So 180 minus theta, we're not going to need the other one, but we'll just still write it down. It's fine. So 7x is equal to, and we say 180 degrees minus 60 degrees plus k 360 degrees because the cos graph repeats every 360 degrees, or again, 7x is equal to 180 degrees plus 60 degrees. Of course, that will be way too big, so we won't even consider that. Where k is an element of integers. Okay, so this is what we have with the 7x's. So this is going to be 7x is equal to, that gives you 120 degrees plus k of 360 degrees, or Here, okay, you can still check because it's actually dangerous not to check. But yeah, I can see it's going to be bigger than that. Maybe not by a lot, but it will still be. So them together will give you 240 degrees, right? If you take 240, so we just check it out immediately. 240 and you divide by 7 because we're going to still divide by 7. Do you see how much that is? 34.28. Okay, so it's fine. We can still write it down. It would have been 240 degrees plus K 360. It won't be part of our range, of course. Yeah, this one was just going to be way too big, so I didn't even want to write it down. But okay, for the sake of, having everything down, it's fine. This would have been divide both hand sides by 3, and then you would have had x is equal to 180 divided by 3 is 60, which is beyond your domain. So that's then plus 120 degrees, again, k of 120 degrees, where k is an element of integers. Okay, so now we can just continue here. Let's focus on these ones. Here, when you divide both hand sides by 7, let's see what we get. Remember, don't forget to divide that by 7 as well. So x would be equal to, and let's find out what that would be. Okay, 120 divided by 7 is 17.14 degrees. And then 360 divided by 7. 360 divided by 7 is 51 point, yeah. So plus k of, we can leave it like this, 360 over 7. Okay, 360 degrees over 7. It's just easier like that to work with it. And then, or this one is the 240. So here, x is equal to, and we can just put that there. So 240 divided by 7 is that 34. Okay, it's still beyond it, but we can still write it. So 34 point, that's going to be 29. Okay, 29 degrees, and then same thing, plus k of 360 over 7. Okay, so it doesn't round up, and we can just see what is going on there. Okay, so remember the answers you're only allowed to accept are from 0 to 30 degrees. So let's see. With the first one, the numbers that would work here, x would be equal to the following. So here, 0 would work, definitely. But if you start going behind, like 0 plus 1, okay, times 120 degrees, then if you start going ahead, it's not going to work. If you go behind as well, it's not going to work. If you change this 1 to negative 1, that's just going to end up being a negative 120 degrees, which is beyond our domain. So we won't even go further with that. Only 0 degrees would work here. Here, if you try that, it's not going to work if you go forward or behind. So 60 plus 1, and then, yeah, it's way too big, okay? Because it's going to be 60 plus 120, which is 180. And then if you go behind by making that negative, that is going to be, so it's negative 120 plus 60. 60 minus 120, which gives you negative 60. It's also beyond your range. So nothing there would work. And then we move on to this one. So with this one, when k is equal to 0, okay, you see that it's going to work. We have 17.14 degrees. That works. That's within 0 to 30 degrees. And then when you go forward, if you make that equal to 1, so 17.14 plus k, and then, let's just make that 1. 360 degrees over 7. Let's see. Okay, so that's beyond our range. It's 68, okay, so it's past that. If you changed it to a negative 1, okay, if you change that from positive to negative, then you get negative 34 points. So it's also still beyond it, okay, because it's past 0. So we're not going to take that. Remember, the values you can substitute for k are integer values. That's why we say k is an element of integers. Okay, so there we also see what works. That's done. This one, we can try negative 1, I guess. That's what we can try. So 34.29 plus, and then if you say negative 1, because if you go positive 1, if you add 0 there, right? If you say times 0, then these two would just give you 0, and then you have 34.29, which won't work. If you add 1, it just makes it bigger, and so it's definitely not going to work. So let's just try negative 1. Okay, and then you will say times 360 over 7. And of course, that's not going to work again, okay, because it's negative. It ends up being negative. And that, of course, is because 360 over 7 is about like 51 point that. So it becomes big enough to make that negative. Okay, so we can see the solutions that we get is just 0 and 17.14 degrees. And this one does not work here. So that will be our answer. We can just say x is equal to 0 or x is equal to 17.14 degrees. And those will just be our answers here. Okay, so it's between 0 to 30 degrees. Okay, that was messy, but okay, so that is it for that. And then we move on to question 7, which is more on trig graphs. Okay, so moving on to question 7. Okay, question 7 says, in the diagram, the graphs of f of x is equal to 2 cos of x plus 1, so that's f, and then the next graph we have is g. Sine 2x are drawn for the interval where x is an element of negative 180 all the way to 180 degrees. Okay, the first question is to write down the range of f. Okay, so do you see what f looks like? It's 2 cos x plus 1. So with the 2 cos x graph, okay, the cos graph naturally looks like this. It just goes from 1 and goes down and then back to 1 again. Okay, so naturally it would have gone to 1 and then the lowest would have been negative 1. But then the minute you say 2 cos x, then that is not going to change. It's not going to go to negative 1 anymore. It will go to negative 2 and the highest it will reach will be 2. But then this is a 2x plus 1. So it shifts this graph up by 1 unit. So instead of it stopping at 2, it's going to reach 3, okay? And then the lowest, instead of it being at negative 2, it's going to be at negative 1. So you can see that the range is just going from negative 1 all the way to 3. Okay, so we can tell them the range, or you can just tell them the y values. Y is an element of, and it goes from negative 1 all the way to positive 3. And that's our answer there. Okay, so that is our answer. Moving on to the next question. The next question, 7.2, says, write down the period of g. So the period of g, this is g, and you can see that there is a 2 in front of the x. So you see how this part affects the range? Well, this, the number that is put in front of x, the coefficient of x, will affect the period. To find the new period, you can just say the old period. You know that this is sine 2x. The sine graph naturally has a period of 360 degrees because it takes 360 degrees to complete one cycle. Okay, it ends at 360 degrees. This is one cycle of the sine graph. So you'll say that 360 degrees divided by that number that they put there. So divided by 2. So it means that the new period is 180 degrees. Moving on to the next question. The next question is, for which values of x in the interval where x is going from negative 180 to 180 is f increasing? So they want to find out, where is f increasing? Okay, remember, when graphs increase, you read them first of all from the left to the right. Okay, so when it's increasing, it's just moving up, right? And then you know it's increasing. So let's look at where f is increasing. This is f. Okay, do you see that it is increasing from here, from negative 180 degrees, it's increasing all through until it reaches its maximum. Okay, so we need to find out where that is, and it's kind of clear here. Okay, and then after that, it starts to decrease. So that's really what we need to tell them. We'll tell them that x is going from negative 180 degrees to wherever this maximum is, and we know it is still exactly where it should be. Okay, the only reason this cos graph looks different is just because of where they started, at negative 180 to 180. Okay, so instead of it looking like, the way it usually does, it looks like this because it's actually still like that. It's just been cut off at this part. So it doesn't have a chance to do that again. Okay, so the answer to that would just be, this is from negative 180 degrees all the way to 0 degrees. Okay, and that's where it will be increasing. Okay, so we can just answer them. You can put it as a set. You can put it in interval notation and set builder notation. So here I can tell them that x is greater than negative 180 degrees, but less than 0 degrees. Or we can say x is an element of, and it's going from negative 180 degrees all the way to 0 degrees. Okay, so another way to say that is actually just to remember what the cos graph looks like. Remember that it will always go like that. And so at this point, that is the turning point. So at that point, that specific point, it's neither increasing nor decreasing. Okay, and then here after that, it's going to be 90 degrees. And then this will be 180 degrees. And then that will be 270 and then again 360. So here, that's where it's 0. Here, this is where it's negative 180. The 90 is not really here anymore since the graph has been shifted up. Okay, so the 90 will probably be here. But yeah, so that's why I'm not going to put square brackets here. And that's why I'm not saying it's equal to. Okay, because at those points, it's neither increasing nor decreasing. That's where it's stationary. Okay, so that is it for that question. Moving on to the next question. Okay, 7.4 says, use the graphs to determine the values of x in the interval where x is. Okay, so same domain. We have to find out where g, the graph of g, okay, the y values of g multiplied by the derivative of f is less than 0. Okay, these are sine and cos graphs. When you see this, okay, when they're referring to the derivative, they're just referring to the gradient. And interestingly, they spoke about increasing, okay, which also refers to the gradient. So when we have f increasing, this will in fact be where f prime of x is greater than 0. This is where the gradient is positive, meaning the graph is increasing. So here, what's going on here is that we have to take the graph of g, the y values of g, and when we multiply it with the gradient of f, it needs to be negative. Okay, so let's see how that can happen. Okay, so there are probably two ways that this can happen. We can focus on where this will be either increasing or decreasing. So let's start with increasing, just because of the way this graph looks, okay? Because it starts to increase first and then decrease. So if it is increasing, right, meaning the gradient is positive, then what should g be so that when you multiply them, you get a negative value? Okay, a negative value, less than 0. G needs to be negative. So you're going to look for where g, the y values of g, are negative. In other words, where the graph of g lies below the x-axis. And at the same time, or for the same x values, this graph needs to be increasing. Okay, that's the first one we'll look for. And we can go ahead and start with that. Let's start. So first, f needs to be increasing, right? So we're looking for places where f is increasing, which is all through here. It's increasing. But then for the same x values, the graph of g needs to be negative or have a value less than 0. So that would be, where does g have a value less than 0? Where it is below the x-axis. G has a value less than 0 within that region. It's going to be here. Okay, it's not going to be here. It doesn't work here, unfortunately. So at this point, we will just cut off this. Okay, so we'll just start here and then it starts to increase. So these are the only places. So the graph of f, right, its derivative will be positive, and then the graph of g, the y values are actually negative. And then they ultimately give us a value less than 0. Okay, so let's find out where this is. You can see the moment where the graph of g becomes negative. It's right here. And that's a point that we can easily find. You see that this goes from negative 180 all the way to 180 degrees, but you know what's going on with g. It's a sine graph and its period has been changed, so it's more narrow. So if it ends at 180 degrees, it means the original sine graph ended at 360 degrees. And so what would have been the x value over here? It would have been 180 degrees. So that means that the x value here now is 90 degrees. And if we know this one, then we would know this one, okay? So it goes from 0 to 90. So 0 to negative 90 degrees. So that's negative 90 degrees. We know where this starts happening at negative 90 degrees. And then all through here. So it works out all through here for all of these x values until 0 degrees. Now, I would not take 0 degrees exactly because at 0 degrees, the graph of g is 0, right? And now you're taking 0 and you're multiplying it by the derivative or the gradient of f, at that point, it's also a turning point. So regardless, it's going to be 0 times something, which is still 0. They never asked for where this is going to be less than or equal to 0. They just said less than 0. So I won't take that. So I'll be careful not to take 0 degrees specifically as an actual x value, and also not to take negative 90 degrees as an actual x value, because at negative 90 degrees, the graph of g is equal to 0. As you can see, it's on the x-axis. So the answer for that one, for this scenario, would be where x is greater than negative 90 degrees, but less than 0 degrees. Okay, so let's put that one down first. Of course, you can also write these as intervals. So that would be where x is an element of going from negative 90 degrees to 0 degrees. And we're not going to use any square brackets since those specific x values are not included. And then let's check the second scenario. Okay, so the other way that they can multiply and give us a negative value would be if f is negative. Okay, so if the derivative of f, meaning the graph would be decreasing. So where the graph of f is decreasing, and then the graph of g would have to be what, so that you end up with a negative value. The graph of g would have to be positive, so it needs positive y values, and for those same x values, the derivative of f should be negative, so it should be decreasing. Okay, let's see where we can see that on our graph. Okay, let's get rid of this because I don't want it to distract us. Okay, now where is, remember, all we're looking for now is where the derivative of f is negative, so it's decreasing, and we can see that over here. The graph starts to decrease here, okay? And then for the same x values, we need the graph of g to be positive, okay, to have positive y values. So if g has positive y values, it's going to be places where g lies above the x-axis, which is going to be here. So where does g lie above the x-axis within this region? It would be here. That's where g has positive y values, okay? If you map it to the y-axis, that's a positive value all through, okay? Of course, except for 0 and 90 degrees specifically. Okay, so now we can see that the common values that they are doing this for would be 0. Well, not exactly at 0, just immediately after 0, and then till 90 degrees. So with the graph of f, we'll stop here and we'll stop at 90 degrees, wherever that is. So it's maybe somewhere there. Okay, so it would be for all these x values, all of these x values. So that is where x would be greater than 0, not equal to it though, but less than 90 degrees, also not equal to it, because at 90 degrees, you can see that the graph of g has a y value of 0, and at 0 degrees, it also has a y value of 0, but we're looking for where their product give us a negative value, not 0. Okay, so it's these two. So with that one, I'm just going to say, yeah, you should just be careful with the way I write this, because now it's going to look like I'm saying two different things. So I'll leave this down here. Okay, the second one was, or let me make sure I don't write it wrong. I'm saying from 0 to 90 degrees. Okay, so this is where x is greater than 0 degrees but less than 90 degrees. You can use the term U, okay, union, saying that it works for these two scenarios, okay, those two cases jointly. Okay, and then here, to write it in intervals instead would be like this, and you can say union, and then you're saying that it's going from 0 degrees all the way to 90 degrees, and that will be our answer. Okay, so this wouldn't really be the full way of writing it as a set. You'd have to say x and then negative 90 all the way like that, and then at the end you're going to have to tell them that x is an element of real numbers, but it's still fine like this because they're not too strict on notation. As long as you're able to express what the answer is, then it's fine. Okay, so that is it for 7.4.1, and moving on to the next question. Okay, the next question is you need to find where cos x is less than or equal to negative 1 over 2. Okay, there was a graph of cos, that was this one. Okay, so guys, one thing you should notice is they're not going to give you a brand new graph. It's very unlikely that they'll just give you a brand new graph. So it probably is this graph. We're just going to have to unpack it and see how it gets to that. Okay, so from trinomials, right, you would see how you could get this back to be the graph of f. So because this is on the denominator, it's really just like taking this, right, cos x less than or equal to -1/2, and you kind of multiplying both hand sides by 2, okay, to get the 2 back here. So you can have 2 cos x. Now you have 2 cos x, and then it's less than or equal to, and those 2's cancel, and you have -1. So now just take that over. So now you have 2 cos x plus 1 is less than or equal to 0. And there we go. So that's the question. The question is, where is that graph of f going to be less than or equal to 0? Okay, so let's look at that. Where is it less than or equal to 0? Here's your x-axis. Look for all the places where the graph of f is going to be negative. It's going to be less than 0 all through here, right? Less than or equal to 0. It's equal to 0 here. It's less than 0 all through here, even including -180. And then on this side, you see it goes up and then down. Then here again, it becomes negative, so less than 0. Remember, that's below the x-axis. That's where it has negative y values. And then we're going to take whatever that is, and of course, positive 180, because it would work for those values. Okay, so how do we find what this is? Because we know what this is, okay? We know where it ends. But what is this? That shouldn't be so difficult. We might as well just equate that. Since this is the x-intercept, that's where y is equal to 0. So just make y equal to 0. It'll be easier like that. Yeah, that's probably why they did that. So if you said y was equal to 0, you see, you're going to end up with what they had, which was cos x equals -1/2. You end up with that, okay? So at this point, all you have to do is take cos over. So shift cos, and so x is equal to, what is shift cos? -1/2. Okay, so 120 degrees, right? So that's going to be at where x is equal to 120 degrees. Okay, so that tells us what this is. It's 120 degrees, but you know the way the graph behaves. See, if you went from 90 degrees until this point, it's 120 degrees. Then from -90 degrees to this point is -120 degrees. Okay, so there, those are the 2 points that we have there. And so to answer that question, we're really just saying that x is greater than or equal to, okay, because they said it has to be less than or equal to 0. So as long as it has a value less than 0 or equal to 0, it's included. So we're going to say x is greater than or equal to -180 degrees, but less than or equal to -120 degrees. And then along with that, we're going to have where x is greater than or equal to 120 degrees, but less than or equal to 180 degrees. And that will be the answer to that question. Okay, you can also write it as intervals. So that would just be going from, but we'll use square brackets here. So -180 degrees to -120 degrees. And then we would also include 120 degrees to 180 degrees. And that will be our answer in 2 ways. Okay, moving on to the next question. Okay, 7.5, the last question for question 7 says, graph G is shifted 45 degrees to the right to obtain a new graph H. Determine the equation of H in its simplest form. Okay, so the graph of G, right, is going to be shifted 45 degrees to the right. You just need to understand what that shift is going to look like. So we end up with a new graph called h of x, and the graph of G gets shifted 45 degrees to the right. You see, when you're shifting a graph to the right or the left, it will affect the x value. Okay, so it affects x. Now, if it's moving to the right, you're going to say minus. So minus whatever angle it's moving to the right by. And if it's moving to the left, you'll say plus. Okay, very different from when it's moving up. When it's moving up, you simply say plus. Down, it's minus. Okay, but left and right is the other way around. So since we know it's moving to the right and it's going to affect the x value, we're saying g, and wherever we see x, you must say minus 45 degrees, okay? Wherever you see x, and that would affect it. So let's look at what g looked like again. G was this graph, okay? Sine 2x. So what would happen there is h of x is now equal to sine of, and you have first, you have 2, and then where you have x, you're replacing x with x minus 45 degrees. So that's going to be x minus 45 degrees, and then there. Okay, so let's simplify. This is going to be h of x is equal to sine, and now you have 2x, and then minus 90 degrees. Okay, so that is what this looks like. And they want it simplified. Okay, so we can expand this further since they want it simplified, okay, in its simplest form. So it can go further than this. We can use, again, compound angles, okay? The compound angle formulas that we have, the expansion for this would be, so h of x equals, and it's sine. So sine of your first angle, sine 2x, cos of the second angle, 90 degrees. And then the operation sign just stays exactly the same. It's not cos. Then we have cos 2x and then sine 90 degrees. Okay, so here, just remember, cos 90 degrees, that is always going to be 0 because at 90 degrees, the natural cos graph has a y value of 0. So that becomes 0 and it's going to, of course, multiply there. So h of x is equal to sine 2x multiplied by 0, then minus cos 2x, and sine 90, we know that is equal to 1. So it multiplies by 1. And so therefore, finally, h of x is just equal to, so we're going to have those subtract, okay? So it's a negative here, minus cos 2x. And that is our answer. H of x is equal to negative cos 2x. Okay, so that is it for question 7. And then we move on to question 8, which is on 2 and 3D trigonometry. Okay, question 8 says, in the diagram, A, B, and C lie in the same horizontal plane. Okay, so you can see that's like the flat ground of this 3D shape. And then they tell us that AB is equal to AC, as we can see there, and D is directly above A, such that 2AD, so twice the size of this, is equal to BC. So that's an interesting point because 2AD, since AD is already P, then 2AD will be 2P, and that would be the length of BC. We should probably put that down. And then, of course, they tell us that AD is P, like we can see there already, and ABC, that angle is X, so ABC is X. And lastly, DBA is Y. Okay, the first question is to determine AB in terms of P and Y. Okay, in terms of P and Y, there's Y, here's P. You can see that it's part of a right angle triangle. So they want us to use trig ratios here. Okay, so going to use that. P would be the opposite side, and they want you to determine AB. So the other side we need to include is AB, and in reference to that angle Y, that would be the adjacent side. So you can see you're using an adjacent and an opposite side. So which trig function are you going to use? You're going to use tan, because opposite and adjacent. So we can start off by saying that tan of the angle Y, right, is equal to, tan Y equals opposite over adjacent, OA, so TOA, right? So that's going to be P over AB, okay? And then we'll just make AB the subject. That's really all to do there. Okay, so make AB the subject. You can actually look at it as multiplying both hand sides by AB or cross multiplying, but that would just give you AB, and of course tan Y equals P. Then you'll divide both hand sides by tan Y, and then that would just give you AB is equal to P over tan Y. Okay, I just see it as I take this over and it went to the numerator. If I take that one over, it will just go to the denominator. So there we go. AB is equal to P over tan Y. Moving on to the next question. Okay, 8.2 says, show that cos x is equal to tan y. Well, the only place that we had tan y was here, which is p over ab, p over ab. And these two lines are equal. So p over ab. I wanted to do that on this side, but the problem is you can't use cos here. These two are already equal. So, and this is y. This would be y as well. Judging from the fact that AD is a shared side in both of these triangles, and they both have 90 degrees. So one angle is exactly the same and two sides are equal. So these two triangles are congruent, but it doesn't really help here since that would also mean that this is y. So it doesn't form cos x in any way. We need to see how cos x gets formed. So let's just use everything that we can use here. So the only place that x appears is below here. And we know that if you're using x, there's no way you can be using the sine rule, You can't be using the fact that sine x over, the opposite side, which is AC, is equal to, for example, sine of that angle. Since this is x, this is an isosceles triangle, that will also be x. So we can't just say this because this is not going to work, okay? 180 degrees minus 2x over 2p. We can't do that because it's not going to bring cos. Yeah, sure, you're including x, but it doesn't bring cos in any way. So how can we include cos when we can see that x is here and this is not a right angle triangle? Okay, the only other way to include cos here would be use the cos rule. Okay, so use the cosine rule and you're going to use x as the focus angle, okay, that angle that you focus on. So using the cosine rule, we're going to look at it like that, okay? So if this is the focus angle over here, x, then what we're saying is we're going to start by naming the side opposite that focus angle, which is AC. So the formula would be AC squared is equal to, then you say this side, the side next to that focus angle, which is AB, so AB squared plus the other side next to the focus angle, which is BC, so BC squared minus 2 times AB times BC, and then cos of x, okay? I know there's just a formula that you can just memorize to find that angle, okay? But I'll just formulate it here. So with this, what we can do is, because there are 3 terms here, but this is negative where we want the cos x, okay? Where we can see the cos x. So how about we just take that over? So we're taking all of this over. So you have 2 times AB times BC cos x is equal to. So this is gone from the right hand side. All that is left are these two. So we have still AB squared plus BC squared, and then the AC can come over, minus AC squared. Then to get cos x alone, you would just divide both hand sides by 2. AB times BC, again here, 2AB times BC. Then this is going to be cos x equals AB squared plus BC squared. So this is the formula you could have just used and it would have been perfectly fine. Okay, so 2AB times BC. Okay, so this is cos x. Let's just substitute everything we have and that should eventually give us tan y. Okay, so AB, what is AB? AB, we found that to be P over tan y. So in place of that, we say P over tan y. Cos x equals P over tan y. But remember, AB is squared, so squared. Then we have plus BC squared. And you see that BC, we already named it. Okay, it's 2P. We know that already. So it's 2P. We'll say 2P all squared as well. Then minus AC squared. So AC, the side that is exactly the same as AB. So if this one, AB is P over tan y, then AC is also P over tan y. So that's P over tan y. And you see how this is not a problem anymore because it's also squared. So that's squared, and they're subtracting. So they'll cancel. Okay, so then it goes all over this. So we have 2 multiplied by AB, which we know is P over tan Y, multiplied by BC, which we know is 2P. So multiplied by 2P. Okay, so let's just simplify. This is cos X is equal to, we already see that these two will cancel. So on the numerator, you just have 4P squared all over, and numerators multiply. So 2 times P is 2P times 2P is 4P squared over tan Y. Okay, so this is just simplifying. I'll simplify it gradually so that you can see what is going on here. Okay, so what happens here is you have cos X is equal to, and you have 4P squared, right? You can separate them, numerator and that denominator here. So we're saying 4P squared over 1, and we're saying divided by. So divided by 4P squared over tan Y. Now, when you're dividing by a fraction, you can do something called tip and times. So you tip this, meaning swap the numerator and denominator. It becomes tan Y over 4P squared. And then you change the division to a multiplication. So you see here what would happen is 4P squared and 4P squared cancel. And then you're just left with cos X is finally equal to tan Y, because it's just over 1. So it's still tan Y. There we go. Okay, so that is it for that question. Moving on to the next question. Okay, question 8.3 says, if X is equal to 60 degrees, calculate the size of Y. Okay, so how do we find Y if we know what X is? Okay, they made this one really simple. So do you see that the last equation that we have, right? We only have X and Y as the variables, okay? And then of course our functions. So we can just substitute X into here. So we're saying that therefore cos 60 degrees is finally equal to, and then we say tan Y. Now you don't have to be afraid of this, just thinking, but then there's a cos and a tan. No, there's a cos and a tan, yes, but one of them actually just represents a number. This is just a number. Cos 60 degrees represents a value. So we can just simplify this as, we're just rewriting that tan here. So tan Y equals what is cos 60? Well, sine 30, the cofunction of that is a half. So cos 60 is also a half, okay? Then now that we know this, we can finally solve for Y, okay? So you can go ahead and take tan over, or you're really using the second function of tan on both hand sides. And we can therefore say Y is equal to shift tan of a half. And that would be Y. So Y is equal to, and then on your calculator say shift tan 1/2. And that gives us exactly 26.57 degrees. And that is our final answer. And that is it for the trigonometry section. And I will see you guys in the Euclidean geometry section.